right, farmer knows that a certain type of seed is likely to 70% likely, so our population probability is 0.7. We've got 300 seeds, and we want to know whether from these 300 seeds, so this is our sample, yeah? Because it's not every single seed that it's ever been made by or grown, developed, germinated, or sold by this company, I guess. It's just a sample of them. So our sample is 300. So we know that our mean for this sample should be the same as the mean for the probability for the whole thing. So the mean for the proportions for this sample should be the same as the probability for the whole thing. So the proportion should come out the same. Our standard deviation of the proportions for this sample, PQ on N. So we've got square root of 0.7 times 0.3 over 300. So that gives a square root of 7 over 10,000, which is the same as root 7 over 100. So we're looking for the probability that the proportion we get is greater than or equal to 65%. Well, let's find the z-score for 65%. So we've got 0.65 minus the mean, which was 0.7, over the standard deviation, which is root 7 on 100. So the z-score for this one is going to be -1.89. And before I double check my thing I know the next question has got P 65%. Less than or equal to the sample proportion less than or equal to 75%. So I'm also going to want to know Z for 75%. Which should actually, given that this top line will get us the same answer as the other top line, just negative, so this one's going to come out as positive. Okay, let's look at this. Z less than or equal to negative positive 1.89 equals, let's have a look, 1.89, 1.89, 1.89 0.9706 Let's draw this for ourselves. So this is the mean. We want negative 1.89, so we want this area. The area that we've been given is positive 1.89, and it's this whole area. So really the area we're after is going to be the same as this because normal distribution, symmetrical. So Z is less than or equal to negative 1.89 is going to be the same as P. Z is greater than or equal to positive 1.89. Handy. That's why we use the standard, the normal distribution. 1 minus 0.9706, which is 0.0294. So therefore, P, the probability of the standard proportion being greater than or equal to 65% is 0.0294, which is 2.9%. Okay, now we want to know the probability of it being between 65% and 75%. The handy thing about this question is, as we discovered here, the top lines, like, this is Z equals minus 1.89, and this is Z equals positive 1.89. So the probability that it's between them is going to be minus 1.89 less than or equal to Z less than or equal to positive 1.89 is going to be the probability that's less than positive 1.89 minus the probability that Z is less than negative 1.89, which is the answer we got above. So we've got 0.9706 minus 0.0294 gave us 0.9412, so there's a 94% chance. Okay, that's all they wanted, isn't it? Yeah. Question 10. So they've told us straight away P is 0.05 because it causes a painful reaction in 5% of users. The number for this proportion, this sample we've taken is 100. So for AI, we want Px equals 0. Actually, what we want is the probability that standard proportion is 0 out of the 100. So we know the mean of the sample proportions is the same as the population probability, so it's 0.05. The standard deviation of the population proportion is the square root of PQ over N. So we've got the square root of 0.05 times 0.95 over our 100 people. Which is 19 over 40,000. And we're square rooting it. So the probability that sample proportion equals 0 to figure it out, we're going to have to find the z-score for that. So we're going to have 0 minus the mean, 0.05, over the standard deviation, the square root of 19 over 40,000. So that z-score was 0 minus 0.05 over square root of 19 over 40,000, negative 2.294. So let's find the probability that z is less than or equal to negative 2.294, because having no one die, lets us count everything to the left of that. 2.294, well, we're going to be able to find it for positive 2.294. I hate how it's making me restart every time. This is the worst. Well, obviously not the worst. It's annoying. It's a mild inconvenience. It's a first world problem. Okay. And I've already forgotten 2.294, so 2.29. So 2.294, 0.9984. Why am I doing it this way? Why aren't I just using binomial? I've got the feeling, yeah, I've massively read way too much into this question. So we've got 100C0 times 0.05 to the 0 times 0.95 to the 100. It's going to come out as 0.00592, which is 0.59%. Less than 2% of the people react. So this is same as the probability of 0 people reacting plus the probability of 1 person reacting. So, well, we've already got this one. Yeah, 100 C1, 0.05 to the 1, 0.95 to the 99, came out as, that 0.95 to the 100, by the way, is, like, this would have been, anything C0 is 1, anything to the 0 is 1, yeah. Plus 100 C1 will just be 100 times 0.05 times 0.95 to the 99. 0.03708, which is 3.71%. Okay. Question B. We've got n equals 1,000. P equals 0.05 still. And they're saying that in their study, the population proportion was 0.3 was 3%. So we're trying to find the probability that the population proportion was less than 3%. Well, we know the mean for the population proportions. It's the same as the probability overall. And we know the standard deviation for the population proportions. It's the square root of PQ over N. I'm writing it out every time to try and drill it into my brain. 0.05 times 0.95, and we've got 1,000 people. So it's the square root of 19 over 400,000. So let's find the z-score of this. So we're standardizing it so we can just look it up in a normal table. So we're hoping for 3%. So that's 0.03 minus the mean, 0.05. Over the standard deviation, square root of 19 over 400,000, which gives us, I'm glad I have a calculator, 0.03 minus 0.05, square root 19, 400,000, negative 2 point, oh, this is pretty unlikely. So let's find the probability Z is less than or equal to positive 2.90. Wish I knew how to bookmark on an iPad. 2.90, wasn't it? Yep. 9981. Just to remind ourselves, this is the mean, this is what we're after. This is positive 2.9. What we've found is this. What we want is this, which is the same as this. So PZ is less than or equal to negative 2.90. It's the same as PZ is greater than 2.90. So we've got 1 minus 0.9981, which is 0.0019. So the probability that they actually did this and got a sample proportion that was less than 3% is 0.19%. So, I mean, I'm calling something. I don't think that I think they lied. Well, this is, so for question 2, they've asked, what should the researchers conclude? Well, I'd say that their study was bad. Is highly unlikely. Check whether... Well, they need to check whether the test they did was actually random, because they're saying they took a random sample. You know, if this medication has worse side effects, or is unsuccessful, painful reactions. If this medication gives women more painful reactions than men, but you only surveyed men, then it wouldn't be truly representative. Yeah. I would check whether it's a random sample or if the medication itself changed. There's kind of a key thing. The number you're after is, and you don't know this yet, well, you won't learn this at all. It's something that they don't teach in New South Wales, but the idea is you're after a probability of 5%. If it's less than 5%, then you can rule it out. But if it's more than 5%, then you can be fairly happy with it. And this is way less than 5%. But you guys don't know that rule. That's question 10.